two identical cells, whether joined together in series or in parallel, gives same current. It means we have got two identical cells. This is one cell with E and R. This is one more cell, both are identical. E and R, both are identical. Whether when they are connected in series or in parallel, gives the same current. It means when in parallel, that is current in parallel, when it is connected, these two is equal to current in series. A series to an external resistance of 1 ohm. First let us say series connection. Series connection. These two are connected in series, one, another one, through an external resistance R. R is equal to 1 ohm. This is EMF of first battery, this is EMF of second battery, since both are identical. So this is it is in series. So what is the E equivalent? That is EMF equivalent of these two. EMF equivalent is equal to EMF of first one plus EMF of second one, because both are in series. And R equivalent, because R1 plus R2, R plus R is equal to 2R. So this circuit we can draw it like this, simple. It is in series now, connected to an external circuit like this. So where R is equal to 1 ohm. So current through this arrangement when in series, that is E equivalent, R equivalent, this is R. When it is in series, total EMF is E equivalent divided by R. Total resistance, this and this are in parallel, so we can write R plus R equivalent is equal to E equivalent is equal to I current. When these two cells are connected in series, the resistance, the equivalent, the current given by this one, that is the current given by this one is equal to E R plus R equivalent. What is R equivalent? Is equal to 2R. So I in series is equal to 2 into F, where R is equal to 1 plus 2R. This is the equation number 1. When both are connected in parallel, these two given cells when connected in parallel, R into R, this is terminal E, and through this it is connected to an external resistance of R. So E equivalent, what is equivalent EMF? Equivalent EMF of the parallel, this is parallel one. Equivalent is equal to first EMF divided by R, that is E by R, plus second divided by R. Very simple way to remember, divided by 1 by R1 plus 1 by R2, that is 1 by R plus 1 by R is equal to 2 into E by R divided by 2 into 1 by R. This it cancels. So E equivalent is equal to EMF of the single battery. And R equivalent, since both are in parallel, we can simply write R equivalent is equal to R into R and divided by R plus R. We can go ahead 1 by R1, this is the 2 by R. R is equal to R square by 2R is equal to half R by 2. Half into R is equal to R by 2. We can simply write this one, since we are considering this resistance only, both are in parallel, both are identical. Take any one of the resistance, divide by number of resistance, that is R divided by 2. So R equivalent this much. And now he is given I in the parallel is equal to total EMF. Total EMF is equal to EMF of a single cell and divided by the total resistance. Total resistance is external resistance plus R equivalent is equal to R by 2, which is equal to 2 into EMF of single battery plus 2 R plus R, 2R plus R, where R is equal to 2 into epsilon, where R is equal to 1 ohm, is equal to 1 ohm. So 2 plus R, this is the second equation. It is given, the condition is given here. It's current in parallel. This is connected in parallel, this is connected in series. When it is connected in parallel and series, the current in the parallel combination is equal to current in the series combinations. That is, this equal to this one. Or we can simply compare this one by 2 plus R is equal to 2 eval by 1 plus 2R, because IP is equal to this value and IS is equal to this value. Since both are equal, IP is equal to IS, that means this equal to this. So we can cancel this one, or we can write 1 plus 2R is equal to 2 plus R, that is 2 plus R. If we take this R this side, R is equal to 1 ohm. Therefore, the internal resistance, find the internal resistance of the cell. So the internal resistance of the cell is equal to 1 ohm. This is 1 ohm since both are identical. For this given circuit, find equivalent EMF and R equivalent. See, this both are in parallel. This cell and this cell are in parallel, having internal resistance and EMF, internal resistance and EMF, internal resistance and EMF. These two parallel and series with this third one. First we will see the first, this, that is between this point and this point. E equivalent, we know E1 by R1 plus E2 by R2 divide by 1 by R1 plus 1 by R2. How to find out? Divide this one divided by this one plus this by this one, whole divided by 1 by R1 plus 1 by R2. So this is E equivalent, we will call it E dash equivalent. So this is equal to E1 R2 plus E2 R2 divided by R1 into R2 whole divided by R1 plus R2 divided by R1 R2. These two we can cancel, is equal to E1 R2 plus E2 R1 divide by this left out is R1 plus R2. This is E dash equivalent. So this equivalent circuit we can write it as, this is one battery with E3 and R3, and this is one with E dash into R dash. So E dash equivalent into R dash equivalent. So internal batteries, internal resistance is included here. So these two are in series now. Series means we have to add, there is no change in polarity, it means we have to add E3 and E dash equivalent, that is E equivalent. Equivalent is equal to E3 plus E dash equivalent, that is E3 plus E dash equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. This is E equivalent for this one. So this, on combining together, we can write this is E equivalent. We will put the internal resistance, that is R equivalent. What is R equivalent? See, R equivalent for this one, R dash equivalent. What is R dash for these two? R dash equivalent. First we will find out for this one, R dash equivalent. For these two parallel circuit, first we have to, that we call it as R dash equivalent. This is first answer, E dash. So R dash equivalent is equal to, or we will write 1 by R dash. 1 by R dash equivalent is equal to 1 by R1 plus 1 by R2. That is, I am writing only for these two. That is this term. So, which is equal to R1 plus R2 divided by R1, R2. R dash equivalent, on reversing it will become R1 and R2 divided by R1 plus R2. So this is R dash equivalent, and these are in series. It means R equivalent, that is R equivalent is equal to R3 plus R equivalent dash. This is equal to R3 plus R dash equivalent plus R1 R2 by R1 plus R2. This is the expression for the equivalent resistance for this one, R3 into R1 plus R2 plus R1 by R2. So this is R equivalent, this is E equivalent, E equivalent, this is the expression for E equivalent. Two sources of equal EMFs are connected, missing data is in series to an external resistor R. The internal resistance are R1 and R2, where R2 is greater than R1. See, these questions have appeared in JEE Mains 2005. See, I am picking up the questions from the question bank of JEE Mains AIPMT, that is NEET. Some questions from the advanced. I am not making my own questions, nor I take from someone's. It is taken from the JEE Mains. So if the potential difference across the sources, first let us see two sources are connected in series, two cells. This is for cell number 1, this is cell number 2, connected in series across an external resistance. So external resistance, its EMF is E, it is external R1, this is equal to E, this is R2. Two sources of equal EMF, it means this EMF equal and their internal resistance are different. This is V1 potential, terminal potential difference across 1 and across 2, and this is the external resistance R. If the potential difference across the source having internal resistance R2 is equal to 0, it means it is given V2 is equal to 0. See, the given condition is V2 is equal to 0, or V2, see, current is flowing here like this, V2 is equal to, what is V? V is equal to EMF of 2 minus EMF of 2 minus current flowing through this into R2. R we can write EMF, both are same, this is EMF of 2, E minus I R2, ES minus I into R2. So it is given in the question, the terminal potential across 2 is equal to 0, that is V2 is equal to EMF of second one minus current through is, that is EMF minus potential drop across the second cell is equal to 0, or we can write this is equal to I into R2. I into R2 simply RI is equal to E by R2. We can write any form. And if the potential across having internal resistance R2 is equal to 0, then R, we have to find out the value of R. So let us find out the current. So E equivalent is equal to EMF first cell plus EMF second cell is equal to twice of E, and resistance equal is equal to external resistance plus internal resistance of two cells. So I we can write, so I is equal to EMF. EMF is equal to, what is the value of EMF? Is equal to 2 into epsilon divided by R plus R1 plus R2. This is the value of I. Now it is here we got this one, the EMF. EMF is equal to I into R. So EMF is equal to I. So value of I is equal to 2 into D divided by R plus R1 plus R2 into, because this is equal to I into R2. I into, which is equal to I into R2. So we can write it R2 this way, like this, I into R2. So now this we can cancel this. So this becomes, when we take this one, R plus R1 plus R2 is equal to twice of R2, because when it goes, this becomes 1, when we cancel this one, 1. When we take it to this side, R plus R1 plus R2 is equal to twice of R2, R. We have to find out external resistance is equal to 2R2 minus R2 minus R1. Therefore, external resistance is equal to R2 minus R1. This is the answer. Here the option B is the right. These questions appeared in JEE Mains 2005.